Okay, so we are going to now estimate the standard deviation, or by estimating this, we're also going to estimate the variance, which is nothing more than this squared, right? The standard deviation squared is the variance, so we're going to do both at the same time, obviously. So we go to page 332. We are on page 332. If you go there, we have the key concepts, the point estimate. It says that the sample variance is what we will use as a point estimate, even though we know that is not correct. We know that it's different from the standard deviation of the population, okay? But we have nothing else. There's nothing else literally used, so we're going to use that as our point estimate, knowing that we will have to apply a bias to it, okay? All right, so it says sample standard deviation, S is commonly used as a point estimate of sigma, even though it is a bias estimator as described in what we learned earlier that, okay? So the confidence interval, so when we're constructing a confidence interval, we are going to use the chi-squared distribution. Chi-squared distribution is a new distribution for us. Some of you have heard this before. Raise your hand if you've heard it before. Nobody took biology? Nobody takes biology?
A couple of years ago.
Huh?
Yeah.
So the chi-squared, you did the p's, and you remember doing the p's?
Oh, yeah. Square?
Yeah, you used the chi-squared to estimate what was going to happen.
Yeah, we talked about this in AP Bio.
Like all the
Yeah.
But I dropped the class before we could.
Okay, all right, that's okay.
talked about
So
it.
chi-squared distribution is a completely different distribution. If you go to page 333, it shows you the chi-squared distribution. So if you can look at the one on the right-hand side, you can see as the degree of freedom, and we've talked about degree of freedom. Where do we use that at? When did we use the degree of freedom? The t distribution, yes, winner there. T distribution, we do the t distribution, okay? The degree of freedom was n minus 1. We took the sample size, we subtracted 1, and that was our degree of freedom, okay? So the degree of freedom, as the degree of freedom goes up, the distribution changes from a skewed to the right. The red one, it looks like it's definitely skewed to the right. But as the degree of freedom goes higher and higher, you can see it moves over to a little more something that looks almost like a normal distribution there. Okay? All right. So that's how the chi-square distribution works. If you go on top of page 333, there is a formula to find the chi-square distribution. Disregard that, you do not need to know that. Okay, so yeah, don't worry about that one. Okay, so the chi distribution is skewed to the right, unlike the normal t distribution. Values of chi-square can be 0 or positive; they cannot be negative. Okay, just like any other one. Chi-square distribution is different for each number of degree of freedom. As the degree of freedom increases, the chi-square distribution approaches a normal distribution. We talked about that. Flip the page. Okay, caution. Table A-2 for the standard normal distribution provides. Okay, A-4 is where the chi-square distribution is. So let's take a look at that. A-4 is on page 690. Page 690. It actually starts at page 688. I'm sorry, 688. Go to page 688. As you can see, the top graph or top thing there looks a little different, right? It looks different from your normal distribution, right? Okay. So as you go there, you can see on the very left-hand column, there is the degree of freedom, okay, and then there's actually the chi-squared values as you go, okay? All right. So we will talk about that later. So just know that this is where you would find it. And truth be told, you will not be using this table. Most of the stuff will be on your calculator. Okay, so we'll do it off the calculator. Okay, so that's that. Let's go to page 334. Let's get the example number 1. Let's get example number 1. Finding the critical values of the chi-square distribution. The simple random sample of 22 IQ scores is obtained as in example 2, which follows. Construction of the confidence interval requires the left and the right critical values of the chi-squared corresponding to the confidence level of 95% and a sample size of 22. So, if you look here, what they're doing is that they're saying that this is the chi-square distribution with an n of 22, which means that the degree of freedom is what? 21, right? 21. And you are going to find two-tailed, so 5%, 95%, right? It says 95%. We're doing a 95% confidence level. So you want 2.5% here and 2.5% here. Okay, so we have to find the value, this value here and this value here, which gives us that. And that's what we're going to look for. Okay, so if you go to blah, 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 blah. Let's see if we can do this on the table first. Okay, so let's go back to the table. Let's go back to the table 688. Page 688. So we're looking at degree of freedom of what? 21. And we're looking for. Okay, do we have 21?
Yeah.
You do?
Yeah. Or
I don't have it.
looking at the top. Oh, we have 20.
Who?
Is it the top? Is it the top of the graph or the bottom or the side?
Oh, we're on the wrong table. We're on the wrong table 687.
Bro.
688? Mr.
687. 687. Degree of freedom 21. So we are going to look at which one? 0.0025?
35.47.
35.48. What's it called? 35.48, right? So 34, 4?
35.48.
48.
Wait, hold on.
Okay, and the other one is what?
Oh.
21. What's the other one?
Wait, what?
What's the other one here? What?
What other one? 35.
One over here.
35.48.
No, that one's over here. We found that one.
Isn't it the same one? So then
No, how can it be the same one? There's one over here.
you're asking
What's
a lot.
like?
So
Like the same amount.
2.8.
So if this is
2.08.
2.5%, what from here to here is going to be what? 97.5. So find me the data from the 97.5.
10.3.
What?
97.
10.283. 10.283. Everybody see that?
Where?
10.283.
Wait,
Point
where?
975. Point 975.
Oh, this one was
Yeah. Point
I
975.
kind of
Everybody see
understood
it?
it. I kind of got confused.
Everybody found it?
Yeah,
You found it?
Yeah,
Isaac! Isaac! You find it?
Wait, what?
Come on, man!
What?
Santos, help him out.
Bro.
So this
Wait, so is that just for the other 25%?
yes, so this is going to be the chi-squared left. This is going to be the chi-squared right.
Got it.
Okay, we good?
I think so.
We're good, right? So that's what they wanted us to find, I think. Those are the two values they want us to find, right? Okay, so everybody understand how that works? Everybody understand how to read the chi-square table? Once I tell you the right table?
Wait, this says that it's switched.
So are we good?
This hasn't switched.
This is the left. Chi-squared right. What do you mean it hasn't switched?
Well,
It
this
says
says
the
that
10
the left
is the left and the 35 is the right.
I mean, numerically, that would make
Doesn't that
sense.
make sense?
Oh, yeah. Oh.
Why?
The smaller number is generally on the left.
Yeah.
Yes, yes.
Wait, where did you?
10.283?
No.
What?
10.283. Okay. Hmm? We good? We good?
Yeah.
Oh, why did I not round this one up around that?
Yeah. Because
Okay.
he does things his own way.
Great answer.
Okay, so that's we're able to do that. And so we will figure out how to, okay.
Okay.
So if you go to, let's go back to the table. I want to explain to you why I flipped those numbers. We'll go back to the table at page 687. On the very top, what does it say? Area to the right of the critical value. So the area to the right of the critical value here would have been 0.25,
Yeah.
right?
Yes.
Area to the right of this value would have been 9.975. So you understand how that read off? Now you understand why I screwed that up? Why you should not screw it up?
Yes.
Okay.
Yes.
Right.
A little bit.
Okay, so that's that, blah, 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 and we will do the key elements on page 335 tomorrow. Okay?